This is Professor Thompson, and this is number 47 in 3.3. So this is another one about tangent lines and domain. So they want you to find the derivative of f of x and the domain of f. Let's do the derivative first, and unfortunately there's no good trick to do here. It's just going to require some quotient rule and chain rule and whatnot. So the high is x, and the low is 1 minus ln of x minus 1. So the derivative is low d high. So I write the low, and the derivative of the high is 1 minus high d low. So the derivative of the low, the 1 goes to 0, so I'll just have minus 1 over x minus 1, and the derivative of x minus 1 is just 1, so that's it. All over low squared, and away we go. So that's fine for the derivative. You could do some simplification, but I'm not so worried about that. The real problem here is trying to figure out the domain. So let's start with a clean slate here. The function is x over 1 minus ln of x minus 1. There's two problems. ln can't have a 0 or a negative number. So let's start with that problem. Well, this argument, x minus 1, has to be greater than 0. That means x has to be greater than 1. So at best, I can use 1 through infinity. But I also need 1 minus ln of x minus 1. That needs to not be equal to 0. So I'm going to solve when it is 0 and figure out what I can. This right here would be bad. So if that happens, then I have 1 equals ln of x minus 1. If I take e to both sides, then e is equal to x minus 1. And so x would be e plus 1, which can't happen. And that's greater than 1, so I have to throw that one out. That means that to get with these two together, my domain is 1 to e plus 1 union e plus 1 to infinity. I have to throw it out. And that's the end of that problem.